Welcome, welcome, welcome. It is time we get into one of my favorite topics of the entire year in all of geometry, which is proofs. There's lots of reasons why I like this. Sometimes it can involve some real creativity. There's a structure to it. One of the reasons I really like it is because after years of teaching it, I think I have a way of doing it that will help you not only in geometry, not only to get proofs right, but when you have discussions with people about different things, trying to make your point and writing papers for class and so on and so forth. So I think this is a really powerful system. And we're up to our 11th lesson. I don't know why it says lesson 10 in the bottom left corner here. Let's pay attention to the upper right. Lesson number 11. And one of the things I really like about proofs is how they relate to mazes. And what I mean by that is this. Growing up, I loved Captain Crunch cereal, and I liked Highlights magazine. If my parents took me to the doctor's, there was always a Highlights magazine laying around in the doctor's office, and I loved Captain Crunch for breakfast. I didn't get it very often, very rarely, as a matter of fact, but I loved it. And not only did I like the flavor and the taste of it, but I also really liked reading the back of the box and trying to solve all these mazes. Inevitably, the Soggies would kidnap Captain Crunch and they would take him to some bad place, and we had to save him or we wouldn't get our Captain Crunch anymore, and there would be a maze. And what I learned in doing these mazes is in the beginning, I would start at the beginning of the maze and go forward. And then one day this like magical epiphany occurred, and I was like, oh my God, I can't believe this. I realized they were so much faster when you go backwards. Do you remember that? Yes. And then when on the really, really hard ones, I began to realize you could go forward as far as you want, kind of stop, and then go backwards as far as you want, kind of stop. And then there was this maze, this mini maze in the middle. If you could just connect the dots in the middle, you would get it correct. Now, the thing about these proofs is that when you take them for major tests and so on, they're partial credit. A lot of the times we're not, I don't think, going to have that. I think we're going to work around that a little bit. I have a way of doing it, I believe. But it's a really logical process for solving a lot of the things in life that you're trying to prove. So I think it's a very valuable skill to get working to help you and just in problem solving in life. And as far as teaching goes, if you plan to teach elementary school, mazes are a popular thing, and you'll get better at mazes when you get better at proofs, and you'll get better at proofs when you get better at mazes. So what are we going to do today? Well, we have our typical weekly plan. This is the first day of the week, and we have 2 lessons and a quiz. We have some review questions to go over first. Then we're going to have to do a whole bunch of stuff about prepping for proofs and then proving triangles congruent. So let's begin with easy for me to say. Let's begin by doing some review. Find angle X, Y, and Z. Stop and start. You know how this drill works. Okay, so angle Y is directly opposite the 145 for angle B. So that means opposite angles in a parallelogram are congruent. It is also 145. Now remember, any 2 consecutive angles are supplementary. So the missing angle will be 180 minus 145, which is 35. And then the opposite angle to the 35 will also be 35, or the supplemental 145, however you want to look at it. We've been over this already about how thankful I am for that. And in these parallelograms, these rules it's called a parallelogram because what you really have is a piece of 2 parallel sides cut by a transversal. So the same sorts of principles that held true for 2 parallel lines cut by a transversal also hold true for a parallelogram. Okay, remember, for this particular problem, what do you know about the opposite sides of a parallelogram? They're congruent. Very good. Find X. Okay, so 7x minus 11 is going to be 3x plus 5. Opposite side, opposite operation. Subtracting the 3x's gives me 4x minus 11 is 5. Adding the 11, I get 4x is equal to 16. Dividing by 4, I get x is 4. We're not completely done though, because it said to find AD. In order to find AD, I have to substitute the 4 back into the 4x minus 5 expression. 4 times 4 minus 5 is 11. Okay, we have a situation here with a right angle and other angles, and you are asked to find x. Go ahead. Okay, so these two angles, 4x plus 28 and 4x plus 6, clearly make up or comprise the 90-degree angle, so they're complementary. So 4x plus 28 plus 4x plus 6 is going to equal 90. Same side, same operation. 4x's and 4x's make 8x's. 28 and 6, combining those terms, get you 34. Subtracting 34, 8x is 56. Dividing by 8, x is 7. All done. Now, find all the other angles, given that the one angle is 85. Stop and start. Go ahead. So, first off, any two angles next to each other that are adjacent, that's what next to means, they're going to be supplementary. And remember, all of these lines are parallel. That's what the markings mean. So we have all of these relationships going on where the acute angles are all equal to each other. The obtuse angles are all equal to each other. And one acute plus one obtuse adds up to 180. So we just used the fact that an acute plus an obtuse add up to 180. There they are. Now, let's fill in all of the obtuses, because every single obtuse in this diagram is going to be equal, which means they're all 95. Likewise, all of the acutes are going to be equal. So all of the acutes here are 85. Here we go. Three angles of a triangle. You know what they add up to. Find n and then classify the triangle by the measures of the angles, which means tell me if it's acute, obtuse, or right. Go ahead. It's my dog snoring. Okay, so if they all got to add up to 180, then 2n plus 5n plus 23 plus 3n minus 3 is 180. Adding them all up, I get all of my n's are 10n's. 2n's, 5n's, 3n's are 10n's. 20 and negative 3 make 20. Subtracting 20 from both sides, 10n is 160. Dividing by 10, n is 16. Now, what kind of triangle is it? Well, one of the angles is 2n, so 2 times 16 is 32. Another one is 5 times 16 plus 23, that's 103. And the last one is 3 times 16 minus 3, which is 45. The really cool thing here is if you add them up, you do get 180, which reinforces that it has to be a triangle. It works correctly, but it's obtuse because one of those angles is greater than 90 degrees. Next up, the exterior angle of a triangle. Do you remember what the theorem is about that? The measure of the exterior angle of a triangle, that's the 10x minus 15 out here, is always going to equal the sum of the two remote or far away interior angles. Go ahead. Okay, so the two remote or far away guys, 2x plus 6 and 5x, they're going to add up to equal the 10x minus 15. Same side, same operation to start. 2x's and 5x's or 7x's, plus 6, of course, equals 2x minus 15. Now they're opposite side, opposite operations. Always start with the smaller number of x's. I was just working with a student a little while ago, high school student, and he liked to do the minus 10x first. And that's just a mistake. You can still get the question right if you do that. The problem is you're more likely to get it wrong. And naturally, in his problem, the correct answer worked out to 22, and he had negative 22. Very common mistake. So always start off with the smallest number of x's. And then if it is possible to avoid negative signs, you will completely avoid them. And if it's not possible, you'll have as minimal number of negative signs as possible in the problem. So 6 is going to equal, because 7x minus 7x is nothing, 3x minus 52, adding the 15, not 52. I was just telling myself, it's so nice to see me not making mistakes. It's 15 here, not 52. So adding 15 to both sides, 3x is 21, and dividing by 3 I get 7. So I take these from previous slides and I change the numbers. So I forgot to change the 52 to a 15 here, and I forgot to change the 3 to an 8 here. Sorry about that, but I think you can follow along just fine. Next up, 126 degrees there. Find the value of the question mark. Okay, so if that guy's 126, then the supplement of 126, because together they add up to 180, is 54. And this guy here, it's isosceles, so the angle in the corner there is 54. And then 54 and 54 add up to 108, taking away from 180 gives me 72 here. That's the vertex angle. But keep in mind that these are vertical angles, so that's also 72. And then this is isosceles, so angle D has to be 72. Add up the 72 and the 72, I get 144. 180 minus 144 is going to equal 36. That is the correct answer. One last question to go over. Go ahead, stop, and start. Well, we just mentioned a minute ago that the measure of an exterior angle is equal to the sum of the two remote interior angles. So the correct answer is going to be 55, because 80 plus 55 is 135, or think of it this way, 135 minus 80 is 55. You could have also written x plus 80 equals 135 and gotten 55. Any way you look at it. Okay, that's review work of what we've done so far. If I put it into, also, what's the longest and shortest sides of the triangle? Well, the longest side is always opposite the biggest angle, so that would be YR. And the smallest side is always opposite the smallest angle, which, if this guy here is 135, that makes that guy 55. And if that guy is 55, then that's 135. That is 45 over here. So the shortest side is across from this angle at R, which is YN. Little quick summary of what's going on. These are the things that you should know. We're just about out of memory space, so I'm not going to take the time to read them all. But you can pause your video and read through the summary. Those are all the things that, or all the principles that were reviewed in the previous section.